In this video, we are going to understand the concept of regular languages, which are fundamental in the lexical analyzer phase of compiler design. The video is structured as follows. First, I will define an alphabet and string. Next, I will answer what is a formal language. Building on it, I will define regular language. Finally, to ensure a clear understanding, I will go through some examples. Let's start with the idea of an alphabet. An alphabet is a set of symbols where each symbol is considered indivisible, meaning it cannot be broken down further. For example, an alphabet might include symbols X and YY. In this case, both X and YY are treated as single indivisible units. Next, we have the concept of string or word, which is simply a sequence of symbols from a given alphabet. For instance, using the alphabet X, YY, valid strings could be XYY, YYX, or XYYXX. Note that although XYY and YYX both compose from same two symbols but are different strings, as in a sequence order matters. However, a string like YX would not be valid because a single Y is not a symbol in the alphabet. Based on above definition, let's now define a formal language. A formal language is a set of valid strings that can be created using a specific alphabet, following certain rules or patterns. The rules determine which combination of symbols are allowed and which are not. For example, our alphabet is XYY, and our rule is that a string must start with X and end with YY. Then the string XYY would be in our formal language, whereas YYX is also drawn from same alphabet but still not part of our language. Understanding these concepts, alphabet, string, and formal language, sets the stage for grasping the idea of regular languages. Regular languages are specific type of formal languages that can be described by patterns known as regular expressions or recognized by a type of machine called a finite automaton. However, it is important to know that this description is not a formal definition of a regular language that you would use in a job interview or exam. Let's define regular language more formally. Number 1. An empty language which contains no strings is considered a regular language. A singleton language consisting of a single string containing a single symbol is also a regular language. For example, if the alphabet is XYY, the language containing only X is a singleton language, as it contains only a single string. However, a language containing a single string YYX is not singleton language because the string is composed of multiple symbols. Given that language A and B are regular languages, number 3, the union of A and B, denoted as C, is a regular language. Number 4. The concatenation of A and B or B and A is a regular language. Number 5. The clean star of a regular language, such as a clean star, is also a regular language. Any other language that does not meet these criteria is not a regular language. To better understand the above definition, consider the regular language A, which consists of two strings A, B, B. The regular language B consists of three strings A, X, Y, and Z. The union of A and B, denoted as C, is a regular language. C contains all the strings from both languages A and B, that is A, B, B, C, X, Y, and Z. The concatenation of A and B, denoted as D, is also regular language. Note that concatenating A and B is not the same as concatenating B and A. Concatenating A and B means that symbol A from language A is concatenated with all symbols of language B, resulting in AC, AXY, AZ. Similarly, the symbol BB from language A concatenates with all symbols of language B, giving us BBC, BBXY, and BBZ. Finally, the clean star of a regular language, such as A, is also a regular language. It will include the empty string, all the strings from language A, which are A and BB, and all the combinations of these strings, such as ABB, BBA, AA, BBA, and so on. In summary, we have seen how we can create a new regular language by applying the union, clean star, concatenation operations to existing regular languages.
That's it for this video. See you next time. Bye.